So as we had before, we worked with a linear function, which is a straight line, working with the concept, the basics of a linear function. Also with the quadratic function, which is the parabola, you also need to understand the basics. That is for you to be able to sketch that linear, the quadratic function. Basically, we know these guys from the quadratic. Once you have this quadratic, remember you worked with the quadratic equations, all right, where you are given ax squared plus bx plus c is equal to 0. It was an equation that you were working with, all right? So working with a function, you are referring the y values related to the x values. Y is equal to ax squared plus bx plus c. This is the format of the function referring to a parabola. That is the function or the graph that you're going to have in this format. So if you're to consider properly, you will notice that we had this function before, right? From your grade 10 mathematics, remember when you were given these functions, but they were just basic functions. If you still remember, when you were given something of this nature, y is equal to maybe x squared, y is equal to 2x squared, or whatever nature. But those functions, they were just passing at this point, all right? Or maybe it is just something like this, or maybe something of this nature. But now we have an extended part of these functions where we are going to be noticing this parabola or quadratic function having two solutions or two roots. So we're going to notice it passing through 2 points like that. Yes, that condition, we still have it. We can have those functions of that nature where it just passes at 1 point, then it returns back. We can have those conditions. I'm not saying those conditions we are not going to use. We are not going to have them. So we can have such conditions, but in most cases, we shall have an extended part. All right. So we shall have something that is extended. That is what I'm trying to have there. All right. So working with the function of this nature, we have the letter A on our function here that we are seeing, ax squared. The same A that we had when we were given a function, the one that I was explaining before of that nature. Remember, you were writing it in the form of y is equal to ax squared, or it can be y is equal to ax squared plus or minus c. We were not having this bx before, but now it's there. Suppose it's there now. In our grade 12, we have to consider that. So the A, the same concept of that A to say if it is a positive, we're going to have this shape, which is a smiley shape like that. If we're having this shape, we're going to have a sad shape. That concept still the same. So that is the advantage of our recap or the revision, guys, such that some of these terms you actually know them from your previous grade. All right. So like I said, the A determines the shape. So A determines is for the, let's just say for the shape, is for the shape. For the shape. Just in short, so that we do not have a lot of grammar there. So if A is for the shape, what are the conditions? One, we shall have a condition where A is greater than 0, where you are referring to positive values. If you're saying a number is greater than 0, remember your number line, 1, 2, 3, so on. These are positive values. In that case, our function is going to be referred as concave up, which is a smile shape like that, positive. A is greater than, that's a positive. So we refer this as it is what? Concave up. So this is concave up. Concave up, it means it is going up like this, all right? It is going up. That is the concave up. It is facing up, all right? Facing down, concave down. So if we have got a which is less than 0 on another condition. A can be less than 0. That is, we're talking of negative values. All right. You are given a function y is equal to minus x squared plus 2x, whatever that you are having there. Negative. Once you have that negative, you are going to have your shape in this manner, being concave down, facing down. All right. So it is going to be like this, which is the said shape, facing down, which is concave down. All right. Concave down. That is the condition. Okay. This one is going to be a smile shape. So when you are given a function, it is something that it's a follow-up. You don't introduce your own thing. This mathematics, guys, we are just passing something that has been proven before. So once you see a positive here, don't argue with the question. You are going to have a concave up shape like that. Once there's a negative there, you are going to have a concave down. That is the condition there. It's an important part for you to note when answering, just to notice that it is going to help you. So this is the A of the shape. Then we have got the letter C there, this C that we are seeing. All right, take note, we have got the BX. All right, there is we're gonna see where the B plays a role. But we have got this C, the letter C. When X is equal to 0 here, look, you are going to remove this, meaning to say Y will be equal to C. When X is equal to 0, Y is equal to C. So what does it mean? That's our Y-intercept, where the graph or where the function crosses or passes through the Y-axis. So C is for the Y-intercept. That is the condition there, right? So I used 1, 2, guys. I'm just gonna, I don't know, 1 again, 2 again. All right, so C is for the Y-intercept. So this one is the Y-intercept. I explained this condition of the Y-intercept before. When you're dealing with a linear function, we now understand, guys, where the line or where the function, the graph passes or crosses the Y-axis. So we have got the shape. Y-intercept is there. Awesome. In terms of our function, this time, as we can see that in terms of the graph being concave up like this, the shape is this way. Whether we've got something like this or we have got something like this, we have got the turning points there where the graph is now symmetrical. At that point, we are going to notice that there will be a line that is dividing our graph into 2 equal parts. At that point, the graph has got a turning point. At that point, there is no movement at all. We are saying the graph is stationary. There is no movement. That's a turning point. So these are turning points. So how to determine these turning points? As we can see, it is part of our function. We have the part of the Y-intercept on its own, guys. It can be a condition where this function, they differ. There are functions which are symmetrical like this. We can have a line, a function which is symmetrical about the Y-axis. It is symmetrical about the Y-axis. It means the Y-axis divides your graph into 2 equal parts. In that case, your turning point is your Y-intercept. This one, your turning point, it'll be your Y-intercept also at the same time. This graph, it is because the Y-axis is symmetrical. But it is not always like that, guys. It is not always like that. That is why we need exactly to know how to determine the turning point, because we can have a function like this one, more to the negative, but less on the negative, like on the positive like this. We cannot say the y-axis, this time it is something else, somewhere there we do not know. So we need to determine that. So if you understand now the calculations, you are not going to have a challenge because it is no longer the y-intercept. Previously, the y-intercept was our turning point. But this time, look, the y-intercept is here. This is your y-intercept, where the graph passes the y-axis. Let's say this is our y-axis, this is our x-axis. The turning point, maybe it's here. They're differing. So it is not always a condition that when you calculate the y-intercept, you say that's your turning point. You were having that before in your grade 11, 10 there because of the type of the function that you were dealing with. They were restricting you to a certain type of function, which is the same quadratic, but they just wanted you to work with simpler questions. This time, you are not into that. You have to extend now. So what is this extension that we need to understand about our function? All right. So we're going to talk about the turning points. So in this case, let's talk about the turning point or the turning points, depending with the type of function. So it follows that on the turning point concept, depending with your idea knowledge of calculation, but it follows that at the turning point, we've got a lot of things there. So let's just say at the turning point, at the TP, I'm just going to write in short. At the turning point, x is equal to, it follows that number one, x is equal to minus b over 2a at the turning point. That's where this one plays a role, the b, minus b over 2a. This is determining the value of x at the turning point. And this equation that you form here is referred to as the axis of symmetry. There you are at the axis of symmetry. This is the value of x at the turning point. Guys, we're talking of at the turning point. X is equal to this. And thus the axis of symmetry. The axis of what? Of symmetry. You are referring to the axis of symmetry at the same time. They can ask in that manner. That is why I'm referring to this. You need also to put this one into consideration. So therefore, if x is minus b over 2a, therefore the point now, which is the turning point, therefore our turning point will be given as, so therefore our turning point will be given as, remember when you are writing a point, you need the x value and the y value. A point is given like this, x versus y. So if x is minus b over 2a, let's say the x value is equal to 2. How do you find the value of y? You substitute the value of y into the what? Into the function. If x is equal to 2, the y value is going to be f of 2, where you are substituting in place of x, you are substituting 2. Okay? So if our x value is minus b over 2a like this, what about the y value? If x is 2, y is f of 2. So if x is minus b over 2a, what about the y value? The y value will be f of minus b over 2a, which simply means the x value, guys. This simply means the x value, this one, the x value, this one that you obtained, you substitute in your f of x. That is what it means. If you obtain x as 2 at the turning point or as your axis of symmetry, substitute that in place of x, you have your what? Your y value. That's the issue of the turning point. So the line of the axis of symmetry is at the turning point, this one. X is equal to minus b over t, minus b over 2a. That's the line of the axis of symmetry. It is found at the turning point. Okay, so it is very, very important. So like I said, determining the turning point is going to differ with your understanding, like what are you working with? Like you can also use the solutions of the function. Let's say you know the solutions of the function. because sometimes you might be given a condition where you are able to calculate the x-intercept and so on and so on and so on. That part, if you know it, then you can use it to calculate also the turning point that is at the turning point. All right. So also, let's consider that also number 2. Also at the turning point, x is equal to the average of the given solution, the x values for the solutions, which is x1 plus x2 over 2, like this, where x1 and x2 are the roots or the solutions of the function. All right, where x1 and x2 are the solutions, or the roots of the function. These are the x values when y is equal to 0. These are the roots. So the x here that we are talking about here, this x here, this one, that we are saying minus b over 2a, the same value, you could have determined that value by adding the roots, then divide by 2. Or adding the solutions, then divide by 2. You could have determined the same x value using this way. All right, so we're going to talk about that. And this one is not part of our topic now, because you're going to use it when you now have the idea or the knowledge of the derivatives. It also follows that at the turning point, the first derivative with respect to x is equal to 0 at the turning point. So knowing this, you determine the value of x, then substitute just like this. So these are the conditions. You can use this one to find the value of x at the turning point. You can use this to find the value of x at the turning point. You can use this to find the value of x at the turning point. So after determining the value of x, you substitute it into the original function. That one, it is not going to change. You have to substitute it back to the original function. So you see, guys, it is important that you do understand all this. This is about the turning point. Just under this one, we are not sketching the function. We are not into sketching. We are just understanding our function. What does it mean when you are having a quadratic function? What does it mean about the turning point? This turning point found at the axis of symmetry. If you are to consider and to say there are solutions, maybe we are given the solution, the x value, x1 and x2 added together, you divide by 2. That is exactly your axis of symmetry. You need to know all these basics. All right. So not wasting time, we need to know now how to sketch. All right. Working with this quadratic function, sketching the quadratic function. Let's say you are asked to sketch a quadratic function. So to sketch any quadratic function, we can follow these steps. Some of the things we're going to explain as we are referring to the questions. You need to write down the y-intercept. That is to determine the y-intercept, just as we had from a linear function. Remember, the y-intercept is on a condition where x is equal to 0. All right? You need to calculate the x-intercept. Why are we saying intercepts? Intercepts. Guys, we saw from our function, the graph is now passing through 2 possible values. So that is why we are having intercepts, 2 possible values. As we know the x-intercept, whether it is 1 or 2, that condition, we are going to let y to be equal to 0. So in other cases, if they give you as f of x is equal to, you let f of x to be equal to 0. That's your y value. So that is right. The equation in the form, that is what they are saying. Factorize whatever that you have, guys. It is now solving whatever that you are having here. It is to solve. You are just solving. Remember how to solve your quadratic equations by factorization method, by quadratic formula, depending on the method that you're given. Then you're going to obtain the x values from there. Those are the x-intercepts. And those x-intercepts, they represent the roots. Those are the roots or the solutions of the function. These are the solutions or the roots of the function. All right? You also need to determine the axis of symmetry. We talked about determining this. We can use x is equal to minus b over 2a. We can use the condition of adding the roots, adding the x-intercepts, x1 plus x2 over 2, which is the average. We can use the derivative concept if you know that. Okay? Also, you need to determine on that part when you are determining the axis of symmetry. This one is just 1 point, this one. You are determining the turning point there. When you are to determine the axis of symmetry, that is finding this x, you substitute the x value. Remember, I said this into the original equation. When substituting into the original equation, what is that you are doing there of that function? It is to calculate the coordinates of the turning point. So this one, it is just a single point. We're going to take it as a single point. Just determine what? The turning point. You're going to need the turning point. After that, plot the points. Then you draw the function using freehand. This is just a sketch. So when you ask a question, they'll give you, it differs the question. They'll ask you, write down, calculate the it's exam, guys. Exam, they can ask in different ways. Calculate the y-intercept. Then you calculate the x-intercepts. Determine the axis of symmetry. Determine this. Then after, sketch the graph. Or they can just give you a function. Given f of x is equal to this, sketch the function. You need to follow up these stages, whether they tried to split these for us so that we do understand in exam that they give you a stage by stage, then at the end sketch. You need to know these steps. All right. So applying these steps, we are going to just try and use this to answer, just to sketch one. All right. Also, some of these terms I talked about it, about these terms, the maximum value, minimum value, as we are talking about the turning point, it is one and the same thing. The turning point will be at a maximum or at a minimum value as we are going to be having our function. So that part, we're going to talk about it. All right. So like I said, we are going to just need one example to sketch this function, or just to have a sketch of a quadratic function, which is what? Which is a parabola. All right, so in this case, I'm going to use just a simple one. All right, I'm going to use y is equal to x squared minus 5x minus 6. All right, so we need to sketch this graph. Sketch quadratic. That's a quadratic. Quadratic, guys, we just say the format. Remember your format. Ax squared plus what? The highest exponent there is 2. Once you see that highest exponent there, which is 2, guys, please do a recap of your, especially grade 10, grade 11, so that you see those functions that you used to have, because they are going to ask those functions. Here we just need to work with our level, guys, so that we do not waste much time. All right. So using the steps that we had previously for us to sketch, we need the y-intercept, x-intercept, this and that. So let's just follow up these steps. Number one, we are going to need the y-intercept. Remember, I said y-intercept is a condition where x is equal to 0. Oh, that's our C. All right. When you have this function in the form of y is equal to ax squared plus bx plus c. Remember, I said c represents the y-intercept. So that is minus 6. So y is equal to minus 6. Or you can substitute, guys. When x is equal to 0, that's a 0 squared minus 5. In place of x, you substitute a 0 like this, minus 6. So y is equal to what? Simplify this on your calculator. That's a minus 6. So we have the y-intercept of our function. Then we move on to the x-intercepts as we are dealing or working with a parabola where we have got two possible solutions for the x values. All right. So we are going to need the x-intercepts. That's a condition when y is equal to 0 or f of x is equal to 0. The whole of this function must be equal to 0. X squared minus 5x minus 6 must be equal to 0. We have formed a quadratic equation. Guys, how to solve a quadratic equation? It's in your hands now. All right, factorization method. We've talked about that. Make sure they go through the basics. Remember the coefficient of x squared there is 1. So I'm just going to have two brackets. Equate these ones to 0. Since we've got 1, going to have x and x here. X times x. That's x squared. So I'm going to take the constant negative 6. What are the products, the factors of negative 6? But these factors must add up to negative 5. Two products, two numbers. You multiply two numbers to get negative 6. Which numbers can we use? Negative 6. All right. Let's say I've got negative 6 and 1. Right. Let's say I've got 6 and negative 1. Let's say I've got negative 3 and 2. Let's say we've got 3 and negative 2. These are products of negative 6. But we only need a condition where we add to get a negative 5. We add. Which one will give us a negative 5? That is this one. Minus 5 and 1. I mean minus 6 and 1. These will give us what? Negative 5. So that's negative 6 and what? And 1. Negative 6 and 1. So guys, we do understand from the 0 concept, one of these brackets must be equal to 0. X minus 6 must be equal to 0, or x plus 1 must be equal to 0. So what is the x value? Minus 6 to the other side will give you a positive. Or x is equal to 1 to the other side. That is going to give us a negative 1. So we have the roots, the solutions, the x-intercepts. Our function is going to pass through these points. It's going to cross the x values here at 6 and minus 1. So it is very, very important, guys. Very, very important to know this. All right, let's move on. We said we are going to need the axis of symmetry, which is definitely what we need here is the turning point. The turning point. So for you to have the turning point, all right, for you to have the turning point, that's the third thing that we are going to need here, which is the turning point. We said we can use the condition, the value of x at the turning point is what? At the turning point. That is the most important part. All right? At the turning point. At the turning point, we do understand that x is equal to what? X is equal to minus b over 2a. All right? So we can have the value of x there. X is equal to minus b over 2a. All right? This is a, this is your b, this is your c. Remember the format of the quadratic, ax squared plus bx plus c. So we've got a, b, and c. All right? So that is minus b over 2a minus b, which is minus our b is what? Negative 5 like this over 2 times a, our a is 1. So that was going to give us the value of x. Negative, which is positive. So it was going to be 5 over 2. Using this idea. But I also said at the turning point, what is it that we understand? Another way at the turning point, x is equal to the average, that is x1 plus x2 over 2, which are the x-intercepts, the roots of the function or the solutions, which simply have to add the roots here, these ones that we obtained. Remember, we obtained 6 and what? minus 1. You add these two. 6 plus minus 1 over 2. Simple like that. So 6 plus minus 1, that's 5 over 2. As you can see, I've got same answer. Or you can use the derivative, all right? For those ones who are into derivative for now, we are into functions, guys. We're going to see that when we talk about the derivatives. That's another way. The first derivative must be equal to 0. All this, it is determining one thing, the value of x at the turning point, which is the axis of symmetry. You have the same answer. Then you can determine the turning point now. So the turning point, that is now the condition where you are substituting. Remember, it's a point made up of x and y. So the y value, where are we going to have it from? By substituting now the value of x that you obtained into our original function. Remember our function that we had, y is equal to what? X squared minus 5x minus 6. Now our x is what? We obtained that x is what? 5 over 2. So we're going to substitute now. When x is 5 over 2, so you're going to have 5 over 2 squared minus 5 into 5 over 2 minus 6. Substituting that. That's obtaining now the value of x. The value of y from there. All right? That is obtaining the value of y, which is corresponding at the turning point. So each and every part is important. All right? So this one was going to give us something like negative 49 over 4. All right, so this is about determining all these negative 49 over 4. Just for the sake of revision, since we are to sketch, we just need to know 5 over 2. It is same as 2,5, something like that, so that we can see where it is going to pass. Then this one is approximate. It's just like minus 12,25. Minus 12,25, all right? So that is it. We need to sketch. With this information, we can now sketch our function. So take note here. We also have from this part, y is equal to x squared minus 5, the coefficient there of x squared. Our a is equal to 1. That is, a is greater than 0. Remember, we said this one, it is going to give us what? A smiley shape like this, meaning to say it is going to be concave up. Okay? A is greater than 0. A is equal to 1. It's a number which is positive, greater than 0. So let us try to have our sketch. So in this case, guys, it's just a sketch, this one. We're just going to have our sketch. I hope you understand me on this part. All right, let me just remove this part. Let's hope you understand me here. So you're going to have our Cartesian plan, the x values and the y values as usual. All right, so let us just say this is what we have. This is our x, that is our y, this is our origin. Okay, so you'll be definitely having values, guys. Remember, this is the negative side. There you are going to the positive. Negative side, there you are going to the positive. So you're just going to mark important points in this case, all right? So let us have y-intercept. Remember, we said the y-intercept, this is the y value at minus 6. Minus, it's in the negative region. So it's going to depend, are you given, but no, normally it's just a sketch, guys, all right? So you have to just mark, you can even write the numbers 1, 2, minus 1, minus 2, minus, guys, it's up to you, all right? This one is just a sketch. So I can easily mark a point here to indicate minus 6. Let's say this is where I have minus 6, which is my y-intercept. Okay, then we move on to the intercepts. The intercepts, x-intercepts, the roots, positive 6 and negative 1. All right, so positive 6, definitely that is to the right side. From 0 going to the right side. That's where we're going to have positive 6. Negative 1 to the left. All right, so let's say positive 6 approximately. It is here. And -1, let us just say it is approximately somewhere here. Let's say this is where we have our -1. These are the x-intercepts. The y-intercept, what else? We need the turning point. All right? We need the turning point. Remember our turning point. This was our turning point minus, this is 5/2 minus 49/4. Like I said, as a decimal, 2.5 and minus 12.25. All right, 2.5, let's just say approximately here, and minus 12. Minus is going to be a little bit down there, guys. Minus 12 is going to be approximately same size like this one going down. So that is approximately 2. 2.5 will be positive. Then minus 12 will be negative, like somewhere here. All right, so we're just going to have an approximation somewhere there. Okay, so this will be our turning point. This one will be our turning point. So as we can see, our function can be sketched or can be drawn, because remember we said this one, a is equal to 1, so it's going to be what? Coefficient of x squared there. It's going to be a smiley shape like this. So your function is going to pass through these points. All right, the -1 to the -6 in the y-axis to the turning point. This one, remember, it's a turning point where it has to go back, right? So this one is supposed to be a turning point, something like this. Then it goes back up. All right, to the 6, passing through the 6 like that. So this is what we are going to have at the end. So that is sketching, guys. Okay, remember this is our turning point. So that's our turning point here, which we said you can have it as a decimal or as a fraction. So as a fraction, remember it was 5/2 negative 49/4 like this. So we have got our turning point. With this information, you are going to obtain full marks. When you are asked to sketch, they want to see all these, the intercepts with the x-axis, the intercept with the y-axis, the turning point. That is the most important part. You have your parabola. So I want you to do as many questions as you can. We're gonna have many classes. Just try to understand these functions and also working with the question papers. So as for now, let us just try to use this idea and the basics of what we had, like I was saying, from our previous grades. We had this parabola. Just go and work out the basics as you had, then add now this part to make up your grade 12 so that it can work. All right, so that it can actually make sense. You just need the basics of your previous grades. Everything will make sense. So let's do, guys, as many questions. Grade 12 is a lot. You need to recap everything that you had before, and at the same time do question papers. So it's actually a lot. So you need to work as much as you can. That's it, guys. Till we meet again.